Hello everyone, in this video we're going to look at homework 3.5 and maybe 3.6 together. So what is domain of 1 over x? What is the range? Okay, domain of 1 over x. 1 over x, you know the denominator cannot be 0, right? The denominator cannot be 0, so domain of x is not equal 0. So if you use interval notation, it's negative infinity to 0, union 0 to infinity. So basically, if you use parentheses, which means 0 is not contained. Okay. All right. So this is the domain. What about the range? The range is also negative infinity to 0, union 0 to infinity. Because 1 over x, if you graph the picture, is like this. You can never goes to you can never reach to 0. Okay. All right. So next one. Identify the graph with domain negative infinity to 1 to infinity. So basically we'll take negative 1 out. And this one is positive, this one is positive, this one is positive 5. I think this one, it takes out negative 1. Okay. Explain how graphs of x over 9 can be obtained from y equals 1 over x. The obtain a graph. So it's basically a shrink or stretch. Okay, so shrink or stretch. Okay, so it depends on how you look at this. So x over 1 is pretty much like this. Okay, so x over 9 is, if 9 times 1 over x, basically the when x equals 1 equals 1 is 1 like this. Now if you multiply by 1, so x equals 1, y equals 9. If you look at the picture, it goes up to here, but it's kind of like you multiply the whole function by 9. Okay, but it still goes to infinity. So you can use the graphing utility to graph this function to see what it means for that. Okay, and then I think if you're talking about this vertically, you can think about y equals x squared. Okay, it's much easier to look at y equals x squared. If you have x squared is like this. If you times something, y equals 2x squared, then you're gonna have something like this. It's going up a little bit, right? Y equals 1 is 2 now here. So this is y equals x squared, x is x equals square. So if you look at vertically, because you multiply on the y values, right? You look at vertically, actually vertically you stretch it to more wider, right? You from here to here stretch it out. So you stretch it vertically. By a factor of 9. Okay. So graph the function. You have to is either C or B. Then you have to check out when x equals 1, y equals 9. So this obviously is wrong, so it's going to be C. Wait. X equals 1, y equals 9. X equals 16, y equals 16. Well, it's 16. A and D are wrong, so it's not C, it's going to be, let me check it. So x equals 1, y equals 9. Let's say 1, 2, 3, 4, 5, 6, 7, 8. Okay, each one is 2, so actually it's here. 1 is here. I made a mistake, I thought this is 1. But the 1 is in the middle here, so it's go up to somewhere it's 9. Okay, then the B is right. The domain of x is the same, negative infinity to 0, union 0 to infinity. Okay, and it increasing. If you look at the picture, it never increase, so it's decreasing function. So it's decreasing at this interval. It's decreasing negative infinity to 0, union 0 to positive infinity. Okay. Next one. Explain that graph can be obtained from this one. You shift it to right by 1 unit. because from x squared to x minus 1 squared, so this one when x equals 1, and then the whole thing becomes 0. X equals 1, then x minus 1 squared equals 0. Basically, x equals 1 is positive 1, so shift to the right, okay, to the right by 1 unit. Alright, so shift the whole thing by 1 unit to the right. So which one shift 1 unit? A shift 1 unit on the right side. Okay, fixed domain. So the domain of x is going to be negative infinity to positive 1. X cannot be equal 1, so just take 1 out. That is enough. Okay, increasing or decreasing? It's increasing from negative infinity to positive 1, and decreasing from 1 to positive infinity. You don't use parentheses, not brackets. Okay. Alright, so this one you have fx equals x squared minus 16 over x minus 4. X will not equal 4, but if you know that, you can simplify this as x plus 4 times x minus 4. Well, x minus 4 canceled out is x plus 4. But if you graph the picture, you will have a hole in the when x equals 4 and the whole thing equals 8, right? So 4 and 8, there is, okay, so basically it's going to be like this and this, and there is a hole in when x equals 4 here. X equals 4, there is a hole in the middle. So the graph as a whole at the graph x equals 4. Okay, the equation of the vertical asymptote x minus, so there's no vertical asymptote. Wait, vertical asymptote. Let's see. So fx equals, oh my bad, is x squared minus 4x plus 4. I thought it can cancel that out. It does not cancel out. Actually, it cannot cancel. I thought it's x squared minus 16 again. So it's x squared, x plus 2, x minus 2. You see, you cannot cancel it. So there is a x as a vertical asymptote at x equals negative 4. So x equals negative 4 is a vertical asymptote. Okay, so equation of the horizontal asymptote. Horizontal asymptote when x goes to infinity. So basically check out x goes to infinity. What happened? X squared minus 4 over x plus 4. X goes to infinity. You divided both the top and the bottom by x. You got x minus 4 over infinity. And 1 plus 4 over infinity. This is 0, this is 0. So x goes to infinity to the infinity. There's no horizontal asymptote. Okay. Oblique asymptote, you divide it. So x squared minus 4 divided by x plus 4. So what do you got? We can do synthetic division. 1, 0, negative 4 divided by negative 4, bring down 1, negative 4 plus it, negative 4 added 16, 12. So is x minus 4 is going to be, this is the remainder. This is the oblique asymptote. So x minus 4. Next question. Okay, the oblique asymptote for this one is given is y equals x plus 1. It tells you that, so it's x plus 1. The graph function intersects its asymptote at x equals what? So the graph of the function intersects its asymptote. So it has some asymptote at, so let me see. Okay, so when x goes to infinity, this is infinity. So x cannot be equal 1, and x equals 0, then y equals 1. Okay, so I think what does intersect its asymptote. Asymptote, does it have asymptote? It has a oblique asymptote. So it does not have a vertical asymptote. It does not have a horizontal asymptote. It only have this asymptote. So you have this asymptote when that's when y equals x plus 1. When x equals 0, y equals 1, I think it's going to be 0. Find the average values of the graph of the function intersected the asymptote. And with equate the function with its oblique and solve for x. That's what I did. Oh, you have 2. It's a common function. So basically you have this one equals 0. So x squared minus x equals 0. Because it intersects itself, this one equals x plus 1. These two cancel out. You have x squared minus x equals 0. X minus 1 equals 0. So x equals with 0 and a 1. Comma 1. Okay. Does the graph function approach its asymptote above or below x goes to infinity? Okay, so does the graph of the function approach its asymptote from above or below as x goes to infinity? X goes to infinity, then fx goes to infinity because s7 is bigger, right? Approach its asymptote from above or below as x goes to infinity. So the asymptote is like this, x plus 1. So now we want to know if it's approached from above or from below to the infinity. So x goes to infinity is positive. So plus anything is positive. So it's from above. Okay. Basically, it's infinity. You add a little bit thing here, add a 0 thing. So it's going to be infinity. Add a small positive thing. It's going to be approached from above. Okay. So this one. Identify the vertical, horizontal, optical asymptote in the y equals state of the x equals. There's no vertical asymptote. This is what? The horizontal asymptote. You have horizontal asymptote negative 4. Because you look at the picture, you can see that negative 4 is the vertical horizontal asymptote. And if it has oblique asymptote, no, there's no vertical there's no oblique asymptote. The domain is negative infinity to positive infinity. I will not type it in here because there's no restriction, there's no open circle. Okay, so find the sketch the graph of the rational function fx equals 3 minus 3x over 10 minus x. So x not equal 10. You have a vertical asymptote x not equal 10 and it's negative. You can change this into 3x minus 3 over x minus 10. You can the x equals 10 is a vertical asymptote. From the C and D are obviously wrong. It's going to be A or B. So you can check it. When x is bigger than 10, then fx is positive. So it's only be A. When x is bigger than 10, it is positive. When x is bigger than 10, it's negative. So it's going to be A. Sketch the graph. First, you always want to find out the vertical asymptote first. 3x squared plus 6x minus 9x minus 9x plus 4. So you can tell x equals 9, x equals negative 4. That's the vertical asymptote. 9 and negative 4. Okay, so I believe that all of them have that. Now, this is the vertical asymptote. And then horizontal asymptote is x goes to infinity, then y equals 3. And we have horizontal asymptote y equals 3. This is not right. Horizontal asymptote is going to be D. You only have this one, have horizontal asymptote at y equals 3. X goes to infinity, 3. X goes to infinity is x goes to infinity. You can check it's 3. You divide everything by x squared. So divide 6 over x minus 9 over x squared divided by 1 minus 5 over x, divide everything by x squared, minus 36 over x squared. Now if x goes to infinity, this is 0, this is 0, this is 0, this is 0, so it's 3. That's y equals 3. That's the only one have a vertical asymptote, have a horizontal asymptote at y equals 3. Graph this function. There is no, okay, it's all positive. It never can go negative. So B, A, and D are wrong. There is no, when x goes to infinity, it's 0, okay, but x equals 0 is 5, okay, so it's B. There is no vertical asymptote. Sketch the graph, x squared plus 4x over 4x minus 1. You can tell the vertical asymptote is x equals 1/4. Okay, A and B are wrong. It's C or D. Now we look at when x is bigger than 4. What happened? X is bigger than 1/4, or x is bigger than 4. Fx is positive. No, this is negative, so it's going to be only D. Sketch the graph and the rational function. So x equals 3, x equals negative 3. Well, then the thing is, you can cancel it out. You can cancel a lot of things out. Pi and 3 plus x. Although we know that these are the vertical asymptote, x equals negative 8, but x equals plus 8, x plus 3, x minus 3. Something cancel out, this cancel out, this cancel out. So just x minus 8 over x minus 3. Okay, and then we have x equals 3, negative 3, 3 negative 8. So it's either A or D, because you have to take all 3 points away. So we got x not equal 3 for sure. So it's either this one or this one. Now we check when x is positive. X is bigger than, okay, so we approach it and x is negative. You can say x is negative 1. What happened? X is negative 1, is negative, positive, negative, positive, and it's positive, so it's this one. Okay, x is negative 1, then fx is positive, so you can choose that's D. Alright, so find the equation of the function graph. Choose the correct for the graph, correct function for this graph. Alright, so I have the vertical asymptote, we have x. X minus 6, that's the vertical asymptote. So only this one. No, wait. Oh yeah, this one or this one. Oh, is x times what I'm doing. X times x minus 6 is this one, the denominator. Okay, so you can use the graphing calculator to graph this one. You know the vertical asymptote is x equals 1/4. And only this one or this one makes sense. But x is positive, x is bigger than 4 is positive. So it's positive is this one. Okay, because this one x it goes to infinity is negative. You plug it in, f 1.28 equals 1.28 squared plus 2 times 1.28 over 4 times 1.28 minus 1. You find it out by yourself, okay? Now first, horizontal asymptote. Horizontal asymptote when x goes to positive, negative, infinity. So when x goes to positive, negative, infinity, you plug into here. So is you divide everything by x power 4. It's 1 minus 5 over x minus 25 over x squared plus 65 over x cubed plus 84 over x power 4 and minus 8 over x minus plus 3 over x squared plus 323 over x cubed minus 28 over x4. What happened is when x goes to positive, negative, infinity, all of this goes to 0, so it's 1. The horizontal asymptote is y equals 1. Given that negative 4 and negative 1 are the zeros of the numerator, factor the numerator completely. And this is the previous question. Okay, So if x minus 4 and x is that, we can fact numerator fact as 1, negative 5, negative 25, 65, 84. Let me divide negative 4 first. Plug it down 1, negative 4, negative 9, 36, 11, negative 44, and 1, 21, negative 84, 0. Perfect. So I divide by negative 1, plug it down. 1, negative 1, negative 10, positive 10, 21, negative 21, 0. Perfect. This is what I remained, okay? So remain is x squared minus 10x plus 21. Factor this is x minus 3x minus 7. So add the previous two factors. So it's x plus 4, x plus 1, because it's negative 4 and negative 1 is your root, right? Plus 4 minus plus 1 is your factor. And x minus 3 times x minus 7. So basically you have these two factors combined with the previous two factors. Okay, this is how you factor it. Alright, so it might take a lot of time to type it in. I just give you something and you see the answers right, okay? Just continue. I want to look at what's the continue. That's right, what we did is right. And the denominator factor is, okay, you have to factor the denominator. Given 1 and 2 are zeros of the denominator, you have to do the same thing as what I repeat. Okay, so what I did, 1, negative 8, 3, 32, negative 28. So 1 and 2, 1, plug in 1, negative 7, negative 4, negative 4, 28, 28, 0. Okay, so this is the fact. This is the root is 1. Root is 2. Plug in 1, 2, negative 5, negative 10, negative 14, negative 28, 0. Okay, so these are the remaining factors. I factor this one, x squared minus 5x minus 14. The factor is x minus 7, x plus 2. But you have two other factors which is given to you, giving the roots. So x minus 1, x minus 2, x minus 7, x plus 2 will be the factoring for the second answer. So you are going to have this one put it here. Just type it in any number. Okay, so what is that? Let's see. You don't. Is this one? You can check it. If it's wrong, it's okay. But we can tell this is the same thing as what we got. X minus 1, x minus 2, x plus 2, x minus 7. So we got it right. Next one, write the entire quotient of f so that numerator and the denominator I factor in factor form. So basically, the factor you get x plus 1. What it means, you get this x minus 3, x plus 4, x minus 7. Okay, and x minus 1, x minus 2, x plus 2, x minus 7. Don't simplify, so don't cross this one out. I think next one probably ask you to simplify it. Okay. Know that. Okay. So that's just basically just put those two together. Then the common factor numerator is x minus 7. Okay, there's only one thing there in common. Alright, so next one, the discontinuity at the denominator equals 0, 1, 2, negative 2, 7. So 4 numbers will all be discontinuity. Oh wait, let me see what's the problem. Find out what the value will be a point of discontinuity. For example, a whole at 7. Okay, and the x-intercept of the graph. X-intercept means y equals 0. Basically, to solve that y equals 0, you have 1, 3, negative 4 from here. Y equals 0 means the numerator equals 0. Numerator equals 0 means 1, 3, negative 4. And plus, let me see. Oh, negative 1, my bad. Negative 1, 3, negative 4. Okay, what is the y-intercept? Y-intercept means x equals 0. Basically, plug x equals 0 into it. Y-intercept is f0 equals everything is 0 except the last two numbers. So simplified by 7 is simplified by 4. My bad. 4 is 21. 4 is negative 7. No, 4 is negative 7. Simplify again, so it's just 3 over 1. So it's 3 over negative 1 equals negative 3. Negative 3. Find the equation of vertical asymptote. Vertical asymptote is x equals 1, 2, negative 2. Whatever this equals 0. So it's 1, 2, negative 2. 1, 2, negative 2. Okay. You may ask me a question. What about the 7 here? Because 7 cancelled out. 7 is not a vertical asymptote. It's a discontinuity point. You only have a circle point over there. Have an open circle. It does not have a goes to infinity. You only have a discontinuity point at that 7. Determine the point of intersection. Determine the points of intersection of graph with this horizontal asymptote. Horizontal asymptote when x goes to infinity. So the points. Determine the points of intersection of the graph of f with this horizontal asymptote. Horizontal asymptote is what? Is y equals 1. So basically you need to solve x4 minus 5x cubed minus 25x squared plus 65x plus 84 equals x4 because you divide it. You divide the whole thing. X4 minus 8x cubed plus 3x squared plus 32x minus 28, which equals 1. This is what they ask you for. You can multiply both sides by that, and you simplify. Minus 24x squared plus 65x plus 84 equals x4 minus 8x squared plus 3x squared minus 32x minus 28. You cancel this one. Shift to other side is 3x cubed. Shift to other side minus 28x squared. Shift to this side is minus plus 64x. Shift to this side plus 100. 4 plus 8 is 12. 112 equals 0. So then you solve this solution. Solve this quadratic equation. Okay. What do we need to do? I think we have to try 7, see if it works out. Negative 28, 64, 112. So let's try 7, see if it works. 21, negative 7, negative 49, and 5. It doesn't work. So you can graph it. You can use the graphing calculator. Graph this whatever. Use the first you can try it. You can try what give you the roots. Because the quadrat is the cubic function, you have to horizontal. Yeah, you have to horizontal aspect is 1, right? Yes. So you have to try it. Try out one, at least one first. I just tried several. It does not work. 64, 112. I think we have to try negative something. Negative 2, 3, negative 2. Okay, negative 30, negative 32, positive 32, 6, 96 is not working. Okay, so you can try negative 1, 2, 3, negative 3, negative 31, and positive 31 is not working. Okay, so I think the best way, if you're going to do that, you can use a online graphing calculator. Graph the function, what is the x are. You can solve that x. Okay, and okay, this one domain. Oh, x not equal 3 is just a negative infinity to positive 3, union 3 to infinity. Okay. Why does it give you? Then I cannot use it here. But I can look at the problem and see if I can help you with it. A reset button set the value of a equals 5, c equals -2. Check the asymptote on the points box and move the x line to x equals -2. Hold the alt key. Find the slide control. Notice that it's covering the point of curve. Find the b slide. Find what the value. Okay, it's very hard for me to tell, and I cannot see the picture, so you have to do the picture. You can just say find the answer. Negative. Okay, it's -1/2. You just put -1/2 again. I think it's the same thing. I'm going to ask the. Okay, I have to put -12, -0.5. I have to ask the course needing instructor to change all of these problems. Make sure they don't have this anymore in the next semester. The domain for this one is -infinity to -1, union -1 to -3, union -3 to infinity. Okay, I think this part is right, but I'm not going to type in that whole thing. You can check my answer is right. Okay, alright, so this is -3 to -1. My bad. -3 is -3 to -1, -1 to infinity. Okay, you can type in that in. So these are the same thing. You can try that. If you have that, you can use your graphing. Click the graph. If not, then you have to do this. This one I can do it. So it's 1.5, -1, +2, and optimate asymptote just 1. Plug it down 1.5 and 1.5 -0.5 1 3. So this is your oblique asymptote 1.5x plus 0.5. Put that in. It says, let's see, try again, simplify answer. Oh, slope is just a 0.5. It's just 1.5. Okay, that's it. Alright, so